Hello everyone, this is Dr. Chen again, and we are going to be spending some time on looking at building mental models using frequency distribution table. And this is chapter 2 of the textbook materials, and in this chapter we're going to learn how to organize data in such a way that we can make use of the data and kind of turning data into information, if you will. So data is almost like the raw thing, but information is what the managers would need to help make decisions. And so basically we're saying what the managers do not make decisions on based on data, which is so raw and they need to be processed. So what we are going to be learning is what how to process data so that they can be turned into useful information. And this topic here is what the frequency distribution table, among other things. There topics like pie charts, bar charts, that can be used to turn the data into useful information by organizing them in a manner that would lend itself to the interpretation, which we talked about before. So data collection, data analysis, and data interpretation. As managers, oftentimes you would be required to develop mental models so that you can quickly come to the terms with okay, well, given the information, what does it mean? And the example that we have right here is the auto group wants to develop some tools so that they can look at the typical profit for each cell. And in this case, we're talking about the say data presented here. So it's a profit on vehicles sold at last month by the Applewood auto group. So we have all these profit values, and if you do some counting, well, you realize how many there is. So first thing is the sample size. What is the sample size? We call it N. And then you look at the numbers here. So the first one is the 1387. The first vehicle was sold, and close to $1,400 was made. But we also have some vehicles that were sold, and only very little profit was made, like $423 or even less, which is $294. But there's also a vehicle that was sold, and the company was able to make over $3,000 profit. So can we tell what's the typical profit on each sale? Is it closer to, say, the lowest, or closest to the highest, or somewhere in between? We also wanted to find out what around what value did the profits tend to cluster. Basically, find the range that we can say, well, as a manager, this is my mental model. For instance, it might be on average what the vehicles were sold, and say anywhere from say $800 to the $2,000 profits would be made, and this would be the typical range. And we are going to quickly develop a tool that is called the frequency distribution table. And what it entails is we have several columns. The first column is basically creating what we call classes within this distribution. So because the smallest value is the 294, we have a starting point of 200 up to 600, and then from 600 up to 1,000, and then 1,000 up to 1,400. And when we say up to, it does not necessarily need to include the value, say 600, so it might be 599, so that we don't have overlapping classes. And you can tell that these classes are both all inclusive and exhaustive. All inclusive means we are able to put each of these vehicle profit values into one of these classes, and two is we would be able to they are also mutually exclusive, and you would not necessarily put one of these values in more than one class. And so if you look at say these values, the first one 1387 is going to go into the third class between the 1000 up to 1400. If you go to the next one, 1754, it's going to be between 1400 up to 1800. And we do the tallings and end up finding the frequencies when you add the tallings together. Well, this should be 180, which is the number of vehicles sold at this place last month. And then instead of remembering or referring to 180 different price points or profit points, we would have a picture of, okay, well, say 8 of the 180 vehicles, well, we made a profit between 200 up to 600, and so on and so forth. And the highest class includes the value here, which is the highest value, 3,392, and that falls into here, and the 4 vehicles that the company sold, and they made a profit over $3,000, but not more than 3,400. So you can also see that we have an even increment. So it's an interval of 400, and we talk about in class how this interval is determined. And you have 180 vehicles, and next column is called the relative frequency. Basically, we change the frequency into a percentage. Dividing 8 by 180, you're going to see the 0.044, which is 4.4%. And you can see that as a manager, you can see that might be a big cluster. So if you eliminate the top 2 classes, which amount to 10% here, and the bottom class is another 10-12%, so you have approximately the 78 to 80% of the values that are between say 1,000 and 2,600. So the one thing that the manager can say is, well, as a point of reference, when we talk about the mental models, we should be expecting to make anywhere from $1,000 to maybe $2,600. Say 78-80% of the time. But there are times we would be making less money. Perhaps we need to meet the quota, or perhaps is a customer who is very good in negotiating. Or there are times it might be a vehicle that we sell and we mark it up, and the customers are still wanting it because is a model that we don't have a lot in stock, and the customers are very much demanding this product. So this gives us the mental model, and we can continue to use this model or this tool, which is the frequency distribution table, to help us develop some other mental models. For instance, we might be able to say that by stacking up these relative frequencies, you can say for instance 88% of the vehicles that we sold have the profit up to $2,600, because when you stack up all these relative frequencies up to this level, you have approximately the 87-88% of the profit values that are from 200 to 2,600. Likewise, you can also say that 12.8% of the vehicles have a profit between 2,600 to 3,400. So as a manager, you would not be overwhelmed by, say, all the raw data. Here, in this example, it's 180 data points. Some of the examples might entail having 5,000 data points, and as a manager, there's no way that he or she can memorize all these data points. There's one other thing that I wanted to focus on is where is the center of the data distribution. We call it distribution because it's not one data point but multiple data points. And roughly you're going to see that the midpoint would be I would say somewhere here, because if you stack up the relative frequency against you have 10%, and then 23% added to that would be 44%. And the next class right here is where we are going to find the midpoint. So the center of the data distribution based on the frequency distribution would be between 1800 and 2200, and let's say the midpoint is $2,000. So on average, what say $2,000 would be made per cell, and that would be the typical profit on each cell. So you can see this is a great tool, and it's not too difficult to use. And there are some rules of thumb that we call that would help us determine how many classes to have and what would be the interval. And this would be the equation that would be introduced in class, and basically we are going to be setting up an equation that allows us to determine what is the optimal interval. If you have too small an interval, let's say every $100 you have an interval, then you're going to have quite a few. Say from 200 to 3400, you have 32 classes. Whereas if you have too few, like every 1,000, so 2,000 to 12 up to 1,200, and then 1,200 up to the 2,200, so and so forth. And then you have only like 3 or 4 classes, and that's probably not going to be as helpful. You don't want too many, neither do you want to have too few. We'll talk about it in class, and it's something that we want you to capture when you look at the building mental models using frequency distribution table. So until next, this is Caleb Chen.